Let's take a look at the preparation of materials. The way in which you prepare the materials will have a pronounced effect on the manner in which they dry. This, in turn, can influence the quality and finished product attributes. Care at this stage of the process will lead to better results in the end. Good manufacturing practices, also called GMPs, must be followed at each step, and GMPs include things like general sanitation and housekeeping. Of course, cleanliness is imperative. All surfaces and equipment must be clean and should be sanitized with a chlorine solution, which can be easily made from household bleach if you follow the directions on the label or look up instructions on the internet. You also need to wash the incoming raw materials to remove any loose debris that might be clinging to their surfaces. Washing will also help remove insects and other surface contamination. Some processors use a mild chlorine rinse followed by a freshwater rinse, and all water used in the processing area must of course be potable. That is, it must be drinkable. Windows should be screened to keep insects out of the processing area, and no animals, including pets, should be allowed in the processing area. And the list goes on. Cross-contamination is a major area of concern. You do not want incoming raw material to contact your finished product, and this is what we mean by cross-contamination, where the finished product can be recontaminated by microorganisms that are present on the incoming raw materials. Workers handling raw materials should not be handling finished products without taking proper sanitary precautions. Hand washing is a key factor in preventing cross-contamination and the spread of microorganisms in general. Try to have a logical flow of materials through your processing area, even if you are doing things in your home. And the best step is to have total separation of incoming raw materials from the finished product. We have already mentioned that raw materials must be of the highest possible quality. This was done in a previous video presentation. They should be free from bruises, blemishes, and surface contamination. Once this is done, you can move on to the next steps. So let's begin preparing the raw materials. A basic understanding of how drying occurs is necessary in order to understand how to prepare your raw materials. We'll look at this in a future presentation, but right now we can make some generalizations. For now, it will suffice to know that moisture is generally removed from the surface of the material. Once the initial water is removed from the surface, additional water removal relies on moisture traveling from the inner portions of the material to the surface, where it can evaporate. As drying progresses, there is less moisture available to travel to the surface, so drying slows down considerably. You should look at drying as the transfer of moisture from the middle of the material outwards. Knowing that moisture must travel from the inside of the material to its surface for removal, you can address this by cutting your product into thin slices and taking other appropriate measures. Let's look at the basic shapes of foods involved in drying. There are three basic shapes of materials when it comes to drying. Each one presents its own drying characteristics. These shapes are flat slabs or plates, spheres, and cylinders. In this diagram, we see spheres represented in the upper left. Cylinders are shown by the diagram in the upper right, and flat plates or slabs are shown across the bottom of the diagram. Some materials may be dried on the basis of all three shapes. Carrots may be prepared as flat slices, spheres, and cylinders. We will use them as an example to define the basic shapes and show how well they dry. Here we see carrots as the different basic shapes. The uncut carrot across the middle represents a cylindrical form. In all cases, these are unpeeled. However, I do tend to peel them for actual drying processes. In the upper right, we see large chunks of carrots which represent the spherical form, and in the bottom left, these are the flat slabs or plates, and they are fairly thin slices, which is usually the best way in which to dry carrots. Here we see carrots as flat slices, and they dry quite well. In the top portion of the photograph, we have 3 slices of fresh raw carrot, and in the bottom, we see it after drying. You may notice a characteristic change in color and also some fluting around the outside edges of the carrots, which have tended to curl up during drying. Carrots as spheres do not dry very well. At the top of the photograph, you see the carrot before drying. These pieces have a characteristic dimension ratio where the diameter is approximately equal to the length of the chunk, and in that way they can be considered to be spherical. In the bottom of the photograph, you can see these chunks after drying, and they have formed spools or spindle shapes and did not dry very well. Here we see carrots as cylinders. This piece of carrot in the top is approximately 10 centimeters long and did not dry very well at all, as you can see by the piece at the bottom. The characteristic shape and the structure of the raw materials determine how moisture is lost. Carrots have capillaries running lengthwise through them. Cutting the carrots into thin slices minimizes the distance water has to travel to be removed, and it leverages the flow of moisture through the capillaries. If you look at the half thickness of the carrot slice, you will see how far the water must travel to get out of the slice. This is because from the center of the slice, water can either travel to the top surface or the bottom surface, so we tend to look at the half thickness as being the characteristic dimension in this case. In thick chunks, the carrots approximate a sphere. Water has to travel further to escape. There is actually little loss through the sides of the chunks due to the orientation of the capillaries. In its natural shape, the carrot approximates a cylinder. Water has a long way to travel to the ends to escape, and the effect of the capillaries minimizes the amount of water that will be lost through the sides. So drying is very slow. The bottom line is to select a configuration that offers the best opportunities for moisture loss. Generally, flat plates or slabs work well, especially when they are thin. In the case of spherical or cylindrical materials, the moisture normally travels along the radius to reach the outside surface. For this reason, small diameter pieces dry faster than those with a larger diameter. In the diagram on the left, you see a small circle representing a small sphere. It has the radius designated by capital letter R, which is the distance from the center of the sphere to the outside surface. If we double the radius, as indicated by 2R in the diagram on the right, we can see that the moisture has twice as far to travel from the center of this larger sphere to reach the surface. Therefore, the drying process will be somewhat slower. Try to think of how the material will dry in terms of its physical structure and characteristics. One of these is the characteristics of the surface. Berries are a real challenge to dry if you don't think about what their role is in life. Here we see some cranberries which offer a real challenge in drying. The function of a berry is to protect the seeds of the plant, to ensure that there will be a next generation, and to increase their numbers. There is often a waxy outer skin or cuticle to keep the water inside the fleshy portion of the berry, and this is exactly what happens in the case of cranberries, which have an extremely impervious outer layer that will hold on to the moisture even after several days inside a dryer. If nature is working to protect the seeds by keeping the moisture inside the berry, then you are going to be challenged in drying the berries if you leave them whole. The simple answer is to cut the berries in half or mash them before drying. The berries will behave much differently in the dryer then. You may notice that some fruits turn color while they are being dried. Apples tend to brown if you leave them in the air. Oxygen in the air is reacting with the sugars and other components in the apples in this reaction, which we call the Maillard-Browning reaction. A slight browning may not be of concern to you, but you can use vitamin C to help reduce browning if you wish. There are powdered preparations available which can be prepared and used as a dip for sliced apples and other sensitive fruits. You just shake off the excess solution as you remove the apple slices from the rinse. The small amount of liquid remaining on the surface is easily removed in the first few minutes of drying. The vitamin C that is present consumes oxygen and prevents browning. If you prefer, you can use fresh lemon juice, which is rich in vitamin C, or you can use lemon juice concentrate. It will not make your apples or mangoes or any other product taste like lemons. Now we can look at loading the dryer. With sliced material, it is easy to position the pieces in the dryer. You simply place them side by side on the racks in the dryer so that they are spread evenly and are not touching each other or overlapping. Here we see some carambola or star fruit which I have spread on the inside of my dryer on the rack, and you can see that none of these pieces are actually touching each other and none is overlapping with its neighbor. Shredded or mashed material is more awkward to handle. First, you may need to place a mesh on the drying rack to prevent the material from falling through the openings. You may have to do this with small particles as well. My experience has been with small pieces of carrot. As they dry, they will shrink in size and fall through the racks, so I tend to use plastic mesh with them as well. Here we see some mashed material on the plastic screens inside the dryer, awaiting the start of the drying process. Then you will need to spread the mashed or shredded material as evenly as possible on the mesh without getting any excessively thin or thick spots that will alter the uniformity of the drying process. With mashed material, you may also have to stir the drying bed occasionally during drying. Now let's look at the test for doneness. You will need to check your dryer regularly once the product is approaching its final stages of drying. Each product will have its own attributes to indicate that it has been dried satisfactorily. Here we see some ginger slices spread on plastic mesh ready to be dried. After drying, the product should be stored properly in sealed, airtight containers and placed in a cool, dark location. The sealed, airtight containers will prevent air and moisture from contacting the dried product, which can alter its characteristics, and the oxygen in the air can cause negative reactions to take place. By storing it in a dark location, any effects of sunlight can be minimized, and of course the coolness will help to reduce the rate of deterioration of your product. Thank you.